Hello everyone. In this lecture, I'll be briefly going over vertical and horizontal shifting up and down and right and left. So I'll just do a very quick review on those. I already think you should know all these. I'll just do it just to have to make the future example easier. Okay. For example, if is y, sorry, y is equal to f of x, sorry about my handwriting, is equal to f of x plus c, shifting up by c. Y is equal to f of x minus c, shifting down by c. Y is equal to f x minus a, no, actually I'll keep it constant, so x minus c means shifting uh, okay, shifting right by c. Y equal to f of x plus c, shifting left by c. In previous lecture we have learned about reflection in x-axis, y-axis, stretching in vertical and horizontal. In this lecture I'm just quickly giving a review, which is a very simple one, so that's why I'm just giving a brief description in this lecture, because in future example we'll see more of this shifting coming up and down, but we have already saw this in example. I'm just giving you a note. So I'll get started with the actual lecture of today, which is laws of exponent. So we have various laws of exponent, so we'll quickly go over the laws and we'll solve one example, and then we'll talk about exponential e, and that will be all. So let's get started. So exponent laws, the first exponent is if you have same base b, and if you multiply two number with same base, then you can add the exponent. So b x dot times b to the power y, you can write b x plus y. Same thing if you have same base b, and if you're dividing those, then you can subtract the exponent. So b over x divided by b to the power y, sorry, b to the power x divided by b to the power y, you can represent as b x minus y. Okay, so when multiplying, so the rule is when multiplying like bases, keep the base same and add the exponent. When dividing like bases, keep the base same and subtract the exponent from, that's it. So denominator exponent to the numerator exponent, so x minus y. Now if you are, when rising the base with the power with another, keep the same base and multiply the exponent. So b to the power x bracket and power of y, then it's going to give b to the power xy. And again in a times b bracket close to the power x, you can also write it as ax bx. And we already have learned it, b to the power negative x, we can represent it at 1 over b to the power x. And now we'll look into an example. So the first example, 4 to the power negative 3 and 2 to the power negative 8. So we can break 4 into 2 square, and we leave it the denominator as 2 to the power negative 8. And using formula number 3, using formula number 3, we get 2 to the power negative 6 by multiplying 2 times negative 3. And now we have 2 to the power negative 6 divided by 2 to the power negative 8, and then we subtract negative 8 from negative 6, and then we get 2 to the power 2, which is equal to 4. Again, we use this formula to do this portion, and like it says, denominator exponent, subtract denominator exponent from the numerator exponent. So the denominator exponent was negative c, numerator exponent was negative 8, and negative negative is positive, so that's why plus 8, and we get 4. We can do the same thing with the variable. Okay, so it was 2xy3, so 2xy to the power 3 bracket to the power of 4. So we will use this, we will use this number 4 formula. So 2 to the power 4, we will break it down, and y3 to the power 4, and 2 to the power 4 we'll leave it as it is, and y34 we can write y to the power 12 using multiplication of the exponents. And then we are left with 2 to the power y, y to the power 12, and the bottom nothing changed, so it's going to be 2 to the power 1 and y to the power 5. So the same base is 2, so 2y minus 1, and again same base is y's, and y to the power 12 and y to the power 5, so y to the power 12 minus 5. The final answer is 2 to the power 3, y to the power 7. Okay, and we know 2 to the power 3 is 8, so we can represent it like this. So only between the same base you can add the exponent or subtract the exponent or exchange the exponent or multiply the exponent, not between different base. So common base, here there is two common bases, one is 2 and one is y. So between 2 we applied the exponent rules, between y we applied the exponent rules, and we get the final answer. And there is a exponential number e, which will be used a lot. So the number value is 2.71828, and we are just using up to 5 decimal point. Okay, and we'll graph this. So the regular e to the power x graph looks like this. Again, it's any exponential graph will have a y-intercept at 1, so e to the power graph looks like this. Okay, so if you're trying to draw this graph, that means we are having a reflection. Okay, we are having a reflection in y-axis, e to the power negative x, and also we are having a vertical compression by half because of this 2, and then we are shifting the graph down by 1. Okay, so let's see how it is done. Okay, so this is e to the power x, and then e to the power negative x will look like this, reflection in y-axis. Okay, and e to the power negative x over 2 will look like this, and it's gonna intersect through half because of vertical shrinking. Okay, and then it's gonna go down by 1. So now this graph will shifted by 1. So this graph was here, e to the power negative x divided by 2, and we shifted the whole graph by 1, and now new y-intercept is negative half. So yeah, so that's all I had to cover for this lecture. Thank you very much, and please like, share, and subscribe.